we are consuming energy. Yes. Hi everyone, welcome to today's lesson. Welcome to another class of physics on electricity. Okay, on today's lesson I want to teach us how to solve problems on electricity, how to calculate for total energy consumed when somebody is using electric appliances. For example, electric cooker, as we have on the board, electric burner, electric iron, electric whatever. How to calculate for the total energy consumed in such cases. But before we go on to solve this question on the board, I want to tell us that we have different forms of energy, and there are some life activities that you undergo that we use these energies in different forms. For example, yes, if we are using machines, we expend mechanical energy. That is, we use up mechanical energy. Yes. If we use solar to generate power, whatever, or electricity or whatever, we use solar energy. And so, if we come to electricity to use all these electrical appliances, we consume electrical energy. Yes. And that is what the questionnaire asks us. That is what is happening in the board. We are asked to calculate the total energy consumed for someone using an electric cooker rated 1000 wattage for 5 hours. Let's read the question properly so that we know what we are expected to do. I take the question. The question says, what is the total energy consumed? Total energy consumed by using an electric cooker rated 1000 watts for 5 hours. The question asks us to calculate the total energy consumed in this electric cooker that is rated 1000 watts for 5 hours of usage. Yes. Now, what do? It is a simple question and a straightforward question. In short, it is a giveaway question. And also an exam question. What we simply do is to list out the formulas for energy and then choose the one to apply. That is the one that shows the information, the data given to us. So let's list out the formulas for electric energy. Formulas for electric energy. The first one I want us to write is energy, electric energy is equals to what? V square T over R, which is voltage square times time divided by resistance. Okay. Energy again, electric energy. I said there are many formulas for electric energy. Is equals to what? IVT. Electric energy is also equals to what? WT. Another formulas for electric energy, there are many of them, but let us stop here for the moment. Now come back to the question and check the data, the information given to us to know the formula we will apply according to the data given to us. The first data I'm seeing here is 1000 watts, and we know power is what is measured in watt. So I'll write power measured in wattage is equals to what? 1000. I write 1000 watts. Okay. Which other data? I see 5 hours, which is time. So I write time noted by T is equals to 5 hours. 5 hours. So, having written out this data, which formula do we use to solve this problem now? Which formula? I choose this one. You know why? There is W here, there is W here. There is T here, and there is T here. So I choose this formula, the third one. So right now, energy now. Electric energy is equals to what? WT. I'm using this formula to solve because T is the only one that suits the data, the information given to us in this question. So it's equals to WT. Now, time to substitute the information, the values given to us in this question into this formula. I start with the first one, which is W, which is power. What did they give us as power? They give us power as 1000 watts. So I'll substitute 1000 here. So I'll write equals to, or let me write energy. Energy is equals to, I substitute 1000 here for power. 1000. What of T, which stands for time? Did they give us any T? Yes, they give us 5 hours as time. But you know that hours is not the standard unit of time. So for you to use this hours, this time, we will change it, convert it to the standard unit of time, which is seconds. So I'll write, I want to change it now. I'll write this 5 times 60 times 60 again, because I'm changing from hours to seconds. Yes. And that will give us what? It will give us, let me write down our energy first. Energy is equals to, let's calculate, is equals to 1000 times 5 times 60 times 60 again. It gives us what? 18 million. 18 million. So I write 18 million. 1, 2, 3, 4, 5, 6. 18 million. 18 million what? We are talking of energy. Energy is measured in joules. So 18 million joules. But if you are not comfortable with all the zeros, if you don't want to leave it like this, you can convert it to standard form. Yes. And it will be something like this. It will now be, I want to convert this number now, this answer to standard form. And it will be 1, this one, point, this 8, times 10 raised to power. 10 raised to power what? Watch and see. I'll start from here. 1, 2, 3, 4, 5, 6, 7. This is where I put this point. So it will be times 10 raised to power 7 joules. Answer. I hope you understand. Yes. So the energy that is consumed, the total energy that is consumed by using this electric cooker for 5 hours is 1.8 times 10 raised to power 7 joules. It's quite a lot of energy. That is why sometimes in our homes, when somebody plug in all these electric appliances, you observe that the voltage level tends to drop. Yes, voltage drop, because most of these electric appliances tends to draw a lot of energy to themselves. They tend to consume a lot of energy. So physics is like all about our daily life activities. Yes.